In example 2, we're going to solve equations now involving R formula. Now let us study the 3 questions given and discuss the different formats of the question. So they ask us to solve for x between 0 and 360, right? So x does not include 0 and it doesn't include 360, but they'll only include values in between. So let's take a look at the format. We saw that all these questions has a sine, has a cosine. The angles are the same. Okay, part C also, take a look. Now part C, you can see that this part here, 2 sine x cos x, is actually sine 2x. And then plus this term, which is 2 cos 2x equals to 0. Study, there's one sine, one cos, and then the angles are the same. So these are the features of our formula. One sine, one cos, and the angles are the same. But for part A, the right hand side is 1. Part C, the right hand side is 0. And both of them actually use different approach. When the right hand side is 1, we use R formula. Okay, so when the right hand side is not 0, we use R formula. But here, part C, when the right hand side is 0, you cannot use R formula. It's not you cannot use, it's preferably preferable to use tangent. Alright? Use tangent, not R formula. So for part A, now how about let's talk about part B. Part B, you can see a 2 sine A cos A. So again, this one using double angle formula is sine 2A. So let me change it to that form first. So it becomes 4 cos Y minus sine Y equals to 3. So check the format. You have 1 cos, 1 sine, and the angles are the same. So it's a feature for R formula. Check the right hand side, 0 or non-zero? Non-zero. So this confirm part B, you have to use R formula again. So this one is again R formula. Alright, so by observing the different characteristic of each question, you then decide what sort of formula you're going to use. Right, so let's go ahead and use question A and B, we use R formula, and then question C, because the right hand side is 0, we're going to change to a tangent 2x instead, starting from A. So this 2 trigo value will become a single trigo value. So since sine is in front, I'll use the sine function, and then the angle, the number in front is the square root of this square plus this number 1 square. So it's a root 3 square plus a 1 square, ignoring all these signs. Alright, now since the angle is the same, I put x, and then if you are using the cosine function, you will just follow. If you are using the sine function, you just follow. Then you take tangent inverse, second number over first number. So it's 1 over root 3. Right, so evaluating, here you get 3 plus 1, which is 4. Square root 4 will give you answer as 2. Tangent inverse 1 over root 3 will be equals to 30 degrees. So you can see that here there's a compound angle. So sine x minus 30 degree will be equals to 1 over 2. Alright, now since this is compound, I'm going to let y be the compound angle and substitute it in. So sine y equals to half. Basic angle of y will be sine inverse half, which is 30 degrees. And then before I find out the actual values of y, I have to work out the new range. If x varies from 0 to 360, then x minus 30 will range from minus 30 degrees to 330 degrees. So this is the range of y. Now since sine is positive, y lies in the first or second quadrant. Lies in first or second quadrant. So I'm going to not find solutions in the fourth quadrant. Then you will get y equals to, first quadrant will be 30, and then second quadrant will be 150. And then after that, there will be no more solutions. So equating y as x minus 30 degree, I will then get x by adding 30 on both sides of the equation. So adding 30, you get 60. Adding 30, you got 180. And there you go. You have solved the equation using our formula. Right? Now part B, I'll leave you to solve on your own. Let me go to part C. Sine 2x plus 2 cos 2x. Equals 0. Now because it's equal to 0, I can divide throughout by cos 2x. So I divide by cos 2x, divide by cos 2x, and I divide by cos 2x. Now you can see that this becomes tangent 2x plus 2 equals to 0. So tangent 2x equals to negative 2. And here the basic angle of 2x will be equals to 63.43 degree. Working is 2 dp. And then since tangent is negative, we know that it lies in the second fourth quadrant. So therefore 2x lies in second or fourth quadrant. Let's work out the range of 2x first. If x lies between 0 and 360, multiplying throughout by 2, you get 0. Multiply by 2, you get 2x, you get 720. So for 2x, you have to generate values from 0 to 720. So the second quadrant will be 180 minus 63.43. Next quadrant will be 360 minus 63.43. The next two angles can be generated by taking the first angle, adding 360, okay. Why? Because if you have an angle in the second quadrant, this angle, if you add a 360, you're coming back to the same line, which generates the next solution. So you do that to the next angle, which is the second angle, you add another 360. Then after that, you take 476.57, add another 360. But if you add another 360, you find that you have to reject the answer because it's beyond the range of 720. So at the end, I have only 4 answers. And then dividing throughout by 2, you get x equals to 58.3 degrees, corrected to 1 decimal place for all answers, and 148.3 degrees, 238.3 degrees, and 328.3 degrees. So you can see that all answers of x indeed fall between 0 and 360. So that's the end of our current example. We will move back to part B and solve the equation. So part B says 4 cos y minus sine y equals to 3. Now since cos is in front, I'll use the R formula involving cosine function, and the number in front will be square root of 4 square plus 1 square. cosine, the angle is, since you are using the cosine function, the sign here must change, so it must be changed to a plus. Then tangent inverse second number over first number, so it's 1/4 is equals to 3. So on pressing the calculator, you get root 17 cosine y plus 14.04 is equals to 3. Take note, working must be 2 dp. And then now putting the trigo function on one side, got y plus 14.04 is equals to 3 over root 17. And then we will let this be x. So we have cos x equals to 3 over root 17. And we find the basic angle of x. Basic angle will be 43.31 degrees. And x, since cosine is positive, x lies in the first or fourth quadrant. Before generating the values of x, I need to work out the new range of x. So y actually lies between 0 and 360. And then if you add 14.04, you get 14.04 degree. And then you get 374.04 degree. So this is the range of values of x. So x lying on the first quadrant will be 43.31 degree, and in the fourth quadrant will be 316.69 degree. Substituting x by y plus 14.04 degree and subtracting both left side and right side by 14.04 degree, you'll get y equals to 29.3 degree, 320.7 degree, all rounded to 1 dp as the final answer. So that's all for solving equations using our formula when contrasted with other methods.